Have you ever wondered why some objects stay perfectly still while others suddenly spring into motion? The answer lies in the invisible tug-of-war between forces. Today, we'll uncover the hidden rules that decide whether things move or stay put, revealing the science behind everyday actions. After our opening question, let's preview the journey ahead. We'll explore balanced forces, unbalanced forces, compare their effects, and see how these concepts shape real life. Balanced forces are everywhere, quietly keeping things steady. In this topic, we'll reveal what balanced forces are, their effects, and see examples that make the concept clear. To understand why objects stay still or move smoothly, we need to define balanced force. Balanced forces are forces that do not change the state of rest or uniform motion of an object because the net force is zero. This definition is the foundation for understanding stability in physics. Here's how balanced forces affect objects. They keep things steady, prevent sudden stops or direction changes, and sometimes even change shape. No movement means balanced forces cannot move a stationary object, keeping it at rest. No sudden stop refers to balanced forces being unable to halt a moving object abruptly. No direction change highlights that balanced forces cannot alter the direction of an object's motion. Shape change possible means balanced forces can sometimes alter the shape or size of an object, even if its motion doesn't change. Let's look at some classic examples of balanced forces, from tug-of-war to everyday objects like books and walls. Tug-of-war with equal teams pulling at 500 newtons. Each shows balanced forces, as the rope doesn't move. A book on a table experiences gravity pulling down, and the table's normal force pushing up, resulting in balanced forces. When you push a wall, it pushes back with equal force, demonstrating balanced forces. Balanced forces aren't just theory, they're visible in Nepal's daily life, from people standing still to parked buses and signboards. Standing still in Durbar Square is a real-life example of balanced forces at work. A parked bus in Kathmandu remains at rest due to balanced forces. A hanging signboard stays stable because the forces acting on it are balanced. Unbalanced forces are the reason things move, speed up, or slow down. In this topic, we'll define unbalanced forces, explore their effects, and examine vivid examples. To understand motion, we must define unbalanced force. Unbalanced forces are forces that change the state of rest or motion of an object. This definition helps us see why things start moving or stop suddenly. Here's how unbalanced forces impact objects. They start or stop movement, change speed and direction, and even alter shape. Start movement means unbalanced forces can move an object that was previously at rest. Stop movement refers to unbalanced forces being able to halt a moving object. Speed change highlights that unbalanced forces can either increase or decrease an object's speed. Direction change means unbalanced forces can alter the direction in which an object moves. Shape change shows that unbalanced forces can also modify the shape of an object. Unbalanced forces are easy to spot in action, from kicking a football to tug-of-war and braking a bicycle. A football starts moving when kicked, illustrating the effect of an unbalanced force. In tug-of-war, if one team pulls with 700 newtons and the other with 500 newtons, the rope moves toward the stronger team, showing unbalanced forces. Applying brakes on a bicycle creates friction, an unbalanced force that slows the bike. Unbalanced forces drive everyday activities in Nepal, from microbuses on the move to football games and uphill cart pulling. A moving microbus in Nepal is a clear example of unbalanced forces causing motion. Kicking a football in a school ground demonstrates unbalanced forces at play. Pulling a cart uphill in village roads shows how unbalanced forces overcome resistance. Now that we've seen both types of forces, let's compare them side by side. We'll highlight their differences, formulas, and see how they shape motion. Let's compare balanced and unbalanced forces across key attributes. This helps us understand how each type affects objects differently. For force equality, balanced forces are equal and opposite, while unbalanced forces are unequal. Regarding net force, balanced forces result in zero net force, but unbalanced forces have a net force that is not zero. In terms of effect on motion, balanced forces do not change an object's motion, whereas unbalanced forces cause changes in motion. Typical examples include a book on a table for balanced forces and kicking a football for unbalanced forces. Here's how to calculate resultant force, using the formula and examples to distinguish balanced from unbalanced situations. The net force equation is F sub net equals F1 minus F2, showing how to calculate the resultant force. Zero net force occurs when forces are equal, such as 200 newtons minus 200 newtons equals 0 newtons, indicating balanced force. Non-zero net force happens when forces are unequal, like 300 newtons minus 100 newtons equals 200 newtons, showing unbalanced force. These are the essential points to remember when comparing balanced and unbalanced forces. Balanced force means the net force is zero. Unbalanced force means the net force is not zero. Force is measured in newtons, abbreviated as N. Unbalanced force is responsible for causing acceleration. Balanced force can sometimes change the shape of an object, even if motion doesn't change. Balanced and unbalanced forces aren't just theory, they shape our daily lives. In this topic, we'll see practical examples, simple experiments, and how understanding forces helps us explain common actions. Here's how force concepts explain everyday activities, from walking and cycling to playing games. Walking involves unbalanced forces that move the body forward. Cycling uses unbalanced forces to accelerate and decelerate the bicycle. Pushing and pulling objects rely on forces to change their motion. Playing games often begins with unbalanced forces, like kicking a ball or throwing. Let's trace the steps of a simple experiment to demonstrate balanced and unbalanced forces. First, gather a rope and two students to set up the experiment. Both students pull the rope equally from opposite sides, creating balanced forces. Observe that the rope does not move, showing balanced force in action. Next, one student pulls harder than the other, introducing unbalanced force. Now the rope moves toward the stronger student, demonstrating unbalanced force. Balanced and unbalanced forces are the silent architects of motion and stability. They explain why things move, why they stop, and why they stay still. By grasping the difference between balanced and unbalanced forces, we unlock the secrets of walking, cycling, and playing. The science of forces is everywhere, guiding every action, every moment.